All right, everybody, we're going to continue on with our exploration of ratio problems, and this one is going to be about mismatched ratios. There's another category that appears in the test. Now, this is a little bit different than the previous questions that we were handling, which was asking us to basically figure out, given some ratios, given some actual numbers, what would be the total number of one of the parts. This one doesn't give us, these types of questions don't actually give us any numbers. They just give us different ratios and they ask us to compare, one part to another part. Okay, so look at this for a minute. It says the ratio of the ages of Anna and Emma is 3:5, and the ratios of Emma and Nicholas is 3:5. What's the ratio of Anna to Nicholas? So see, here's where this can be a little tricky. We don't have any direct comparison between Anna and Nicholas, right? But what we do have, and this will be always the case with every one of these types of questions, is we have some common link, right? There's a bridge, so to speak, to get from Anna to Nicholas, and that would be Emma, because Emma appears in both of these ratio sets. So what we're really just going to do is make two different ratio columns and go here. Just watch me for a minute here. I think this will make sense as I'm doing it. So I'm going to say this is the ratio set 1 and this is ratio set 2. Now, in ratio set 1, we have Anna and Emma. So I'm going to put A and E, okay? And the ratio there is for every 3 years of Anna's age, it's 5 years of Emma's, okay? Now, ratio set 2 is Emma and Nicholas. Emma is our link, so I'm going to match her up right here. Emma is 3 in this scenario, and I'm going to put Nicholas right here. Nicholas is 5. Okay, so now, here's how we handle this. What we need to do, in order to make some sort of comparison of Anna and Nicholas, we need to make the matching ratio, the same. And the way that we can do that is by finding what is the least common multiple of these two numbers right here, and then multiply. So in this case, look at this. What I can do is I could change, looks like 5 and 3, the smallest number that they both have in common would be 15. So I'm going to multiply this times 3, but then I have to do it to this ratio as well. And I want you to pause for the video for a minute and just think about why that's legitimate, why we can change ratios that way. All right, I'm not going to get into it now, but leave me a comment in the, if this is something that you'd like me to explore. But okay, so on the same note, we're going to multiply this by 5 and this also by 5. And so now that gets us to, we're going to get in this column here, we're going to have A 9, E 15. And just again, think about it. 3 to 5 is the same as 9 to 15. All right, and then this one's going to be N is going to be 25 and E is going to be 15. Okay, so now here's the idea. It's like what we say is that, well, we know that when E is 15, A has to be 9. Well, but if E is 15, we know N has to be 25. So therefore, we can say that the ratio of Anna to Nicholas is 9 to 25. It's like magic. Okay, but that's it. That's really all you have to do. Even if you don't fully understand how this process happened, whenever you're asked to find, sort of a mismatched ratio, right? We're asked what's the ratio of Anna to Nicholas when we didn't have that information in there. We had Anna and Emma, and we had Emma and Nicholas, but we didn't have Anna and Nicholas. All you have to do is exactly this. Set up your ratios, find the bridge, find the thing that they have in common, get those numbers to be equal to each other by multiplication, and then, compare those. That's it. All right, so on that note, let's do one more problem real quickly, but I think you should be able to do this on your own. Let me cut this and clear this out a little bit. But it's very mechanical. These ratio problems, once you kind of understand what it is that you need to do to set these things up, it's not hard to solve. Okay, so let's look at this one. Same sort of thing. Selena collects football, baseball, and basketball cards. They give us a ratio of football to baseball, the ratio of baseball to basketball, and they want to know what is the ratio of football to basketball cards. So since it's asking for a ratio of a mismatched concept, right? We didn't directly compare football to basketball. We know that we have to set up this scenario here. All right, so let's do the first ratio. It's football to baseball is 4 to 2. So I'm going to say football to baseball is 4 to 2. And then the second ratio is baseball to basketball. I hate when they use two B's. I'm going to say B. I'm going to say basketball. I'm going to say BK. Okay. And baseball to basketball is 4 to 1. And then they want to know what's the ratio of football. This is what we're interested in. What would this ratio be right here? Well, this shouldn't be too bad. Well, our bridge is the baseball cards, right? These numbers are not the same, but what's the least common multiple, to turn both of these numbers identically to each other? Well, it looks like it's just 4, right? I could multiply the left column, this row right here. I could multiply this by 2 and this by 2, and that gets me to football becomes 8, baseball becomes 4, and we're done. The ratio is 8-1. And just think about that for a second. What we're saying is that if I've got 4 baseball cards, I must have 8 football cards. Okay? But then we're also saying, well, but if I have 4 baseball cards, I must have 1 basketball card. So that must mean the relationship between football and basketball would be 8. For every 8 cards that there would be in football, there would be 1 card in basketball. 8-1. And we're done. Hopefully that made sense.